And thank you, Pearl, for giving us the talk on the online recommender system.
Thank you for coming. And I wanted to tell you 3 stories about my research work, and assure you these are all true stories. So my research work, the number 1 story is going to be how HCI has inspired my current work on building recommender systems for online users, how it has influenced me to think about computer science and in particular artificial intelligence problems. Second, I wanted to talk about how AI and various other fields can contribute to this booming field called human-computer interaction. And third, I wanted to dedicate some time describing some of the work that we did building interfaces. But before I do that, I wanted to define human-computer interaction and put into perspective for you what are the difficult issues and challenges that face the researchers and practitioners in human-computer interaction field. But before I do that, I wanted to just give a little bit of an overview of the history of HCI. So indeed, when the designers first came up with the first electronic computer called the ENIAC. In fact, ENIAC was designed and developed in Moore School at UPenn in the 1940s. They didn't really think much about human-computer interaction issues. It was a very difficult task because there are about thousands, tens of thousands of vacuum tubes, and it requires connecting the wires in order to program this machine, which occupies roughly 200 square meters. So, in fact, 6 women were tasked to do this job, connecting wires. And only very later on, about 20 years later, we were able to use tapes to interact with computers. And then punch cards, maybe some of us still remember using punch cards to interact and program computers. And finally, in the late 60s, the first terminal was sold and got very popular as a way to use the keyboard to interact with the computers. So how do we actually display the results that computers generated? Again, in the early days, we used light switches, for example, as shown in this photo, and paper and teletypes. So really the field, what we call today HCI, started in the universities in the late 1960s with Evan Sutherland's work on direct manipulation and also Douglas Engelbart's mouse and his work on desktop systems. So this university research led the development of the field. And also corporate research, for example, Xerox PARC developed several desktop computers, but it's not until the 1980s the HCI become really a field of study, and the reason is really the commercialization of personal computers. We know Macintosh, Apple Macintosh. So Macintosh is responsible for popularizing graphical user interface we call a GUI, WYSIWYG interfaces, what you see, what you can get. And this thing was launched in January 1984, and for about 5 months it was sold 70,000 copies and priced at $2,495. But many of us probably did not know that the Macintosh was the idea of desktop computing, desktop metaphor was not invented by Steve Jobs. And it was in fact invented, developed in Xerox PARC Research in the 1970s, and this was considered the very first personal computer. So in the early 80s, in fact, Apple wanted to buy Xerox, the company, in order to commercialize this computer, but the deal never came through. So in the end, they bought the rights to the Xerox Alto and the graphical user interface, the license to use this metaphor to popularize the user interaction. Today, HCI is a booming field. The primary consideration is to design interfaces and interaction methods in order to make computers usable and attractive. And primarily, HCI is a CS concern, but actually it draws upon methods and principles for many fields. For example, cognitive psychology, artificial intelligence, learning technology, ergonomics, and even anthropology. So this is probably the most multidisciplinary field in computer science. So what are some of the subfields that researchers and practitioners are facing in HCI? So I just wanted to run over some of those different subdisciplines. The first one that came to mind is, of course, the I/O devices. This is concerned with designing and developing input and output devices for users to be able to interact with computers, and more increasingly to interact with computers in ambient environment, with mobile devices also, and mixed reality interfaces. And information visualization is concerned with making sense of very large quantity of data, and we call it essentially visualizing the non-visuals. Here, it's an example of the stock market. And what we see here is that the stock market is divided into the sectors: technology, healthcare, and several other sub-areas. And each area actually corresponds to the market capital size of the company, of the individual company. So essentially, it is a tree, but in order to visualize onto a fixed area, it's dividing the area into sub-areas and then gradually into smaller areas. Eventually, each square actually represents a particular company. To make the information even more visible to the user, it's using color to render some information that is important to the end user. For example, here, the green represents the market gain, and red represents the loss of that company. And obviously, this visualization was taken during the years when the stock market was doing fairly well. Today, we will probably see a lot more blacks, which are no gain, no losses, and also in the reds. But a large amount of work is also dedicated in understanding the human society and culture, and what's really going on when information technology is integrated into our lives. And this is the reason why we call it anthropology. So you can imagine, for example, today, social media, social networks, how they influence our lives, how they probably enhance our problem-solving skills, and also the interaction between or among the users in such environments. By far, the prevailing concern of the HCI field is really about usability of software. Mobile applications, online applications, environments, how we interact with computing devices. This is also something that almost everybody in this room can practice, and I will explain to you some of the procedures goes into making the software usable, right, and testing if a software is sensitive to users' needs. So here I wanted to show you also a video that describes, for example, the future of HCI and actually what are our goals in HCI and what we're trying to achieve, and perhaps our bets, our forecast of this field. So some of the technologies are already today, for example, touch screen technology, gesture interface, and also interaction collaboratively in distance. So now I'm going to switch to my own research work. And as I said, the first part of it is about user-centric design of product search and how HCI has influenced the way we look at our problems in artificial intelligence. So for a long time, I'm interested in product search. And let me first define what is product search before I explain why it's a difficult problem and how we solve it in an AI way. So product search is basically how users look through a large collection of options, available options, But what they're trying to do is they wanted to identify a preferred product, and they want to do it accurately and at the same time efficiently, because they don't want to spend a lot of time on this. Well, if you have, so product search has actually a lot of applications, and many of those applications we can very easily relate to. For example, planning a trip, buying a laptop computer, selecting a DVD to watch. Mother's Day is coming. I hope you're thinking about buying a gift, either online or offline. All of this implying that those products can be, in a way, homogeneously described to you by a set of features. But why is it difficult? Well, today, when we look at these products, especially in online environments, we're facing a large collection of options. So practically the online store has unlimited shelf space. Then all of the products actually can be described by these features, but these features can be both blessing and also a curse. Why? Because features help us decide. So if I know exactly the kind of price range, I can use this feature to eliminate all those products that don't want to look at. If I know exactly what type of color, which is another feature, then I can say I only wanted to look at clothes of a particular color. Okay? So it's a blessing, but why is it a curse? Because we now not only have to select one of the options, we also have to decide on the kind of preferences that to me are important for each of those features. And you can see as more there are the options available to us, and the larger the feature set, the problem is more and more difficult. A quick look at the Yahoo Shopping website, I just did it a few days ago, tells me that there are 35,000 digital cameras for an average user to choose from, cell phones, 24,000, and under Mother's Day gift category, what I have is women's watch, and I have, 12,000 women's watch. So now I'm going to shift you back to the late 1990s. This is when the e-commerce emerged. And many of us in AI would represent this problem as a multi-attribute decision problem. So what we do is we're going to look at the utility function of each of the attributes, and we say that if the user prefers a particular range of attribute or a particular feature of the attribute, then this product is more valuable to me. And what I can do is to rank all of my products according to what the user's utility functions are for those features. And then my job is done. I can just pick or sort all of the products in that rank list and present it to the user. Now the problem is that users don't express their preferences in that way, in the way that AI methods want them to express. But you will be surprised that at that time, in the late 90s, there were just so many interfaces that elicit preferences exactly in that way. So in order for us to know how users behave under those conditions, we build actually a number of simulation interfaces, and we test them with our users through interviews and video protocols, etc. So here, for example, is how user may find a a PC, and listed here are all these features that I talked about. And then one by one, we will ask them to tell us what it is their preferred feature. And this, for example, is a commercial implementation of such interface, and we call that the first generation interface for product search. Well, users can tell you their preferences if they don't have any constraints. For example, if they can spend just unlimited amount of money to buy a PC, well, they can just select the features to their heart content, right? So this problem is actually hard because we're dealing with features that are have dependencies, and selecting one feature and its constraints and its preferences limit us on the kind of features that we can select for other part of the system. So the more feature dependencies that you have, the more conflicting problems that you may encounter. But even you take out the constraint of the price, you still may run into other dependencies. For example, if you want to have a very light computer, that limits, first of all, the screen size and probably a lot of other features of the laptop. So once these features come into this kind of dependency constraints, then the problem becomes very, very hard. So how did HCI help us solve this elicitation problem? So basically, we have 5 steps in a procedure called task analysis. We interview the users, like I said. Sometimes we interview users with an interface, or sometimes we just use qualitative survey methods to interview them in what we call needs assessment. And then we design very primitive interfaces, and we try this with our users and see if they actually correspond to their needs in this preference process. And finally, we wanted to evaluate the prototypes with real users. And then that implies that we have to go back to our design and redo some of the features. And we keep improving, and we are in this loop usually for multiple cycles. So the task process is really the detail. We all say that devil is in the detail. For HCI, task analysis is the detail. But it's also a very lengthy process, and I'm not going to bore you with all the task analysis work that we have done. Here, what I want to do is just to show you some examples of cases where we observe problems of users interacting with the first generation interface. So in the early days, we looked at many travel planning tools. And in these travel planning tools, like the tablet PC or the personal PC interface I showed to you, has a very rigid way of eliciting users' preferences. And sure enough, for example, here it shows users don't express their needs and desires in that way. For a simple example here, user may not express preferences in the order anticipated by the system. So in the travel planning, often in interface, we have to answer the question, when are we supposed to leave? But in fact, our business meetings are often decided by our collaborators or colleagues, and they usually say when you should arrive in your destination. Right? So here, arrive in that city by 2 p.m. is often the kind of constraint that we work with. And then we need to define our preferences for the departure time based on that information. And also, preferences may not become relevant until a particular concrete context presents itself to us. So if we fly between Geneva and another airport, we usually don't think about the intermediate airport until, well, the catalog tells us all of the flights would have to stop somewhere before your destination airport. So only then we started to think, do I prefer to change my plane in Zurich, in Munich, another airport, Paris, for example? So this kind of analysis would go on for many sessions with our users. And also users stated their preferences often in conflicts. You probably remember in the early days when we type for asking for a particular product, we often get a message that says results are not found. And that's actually the reason, because people don't really know the dependencies, the constraints among these features, and they ask for something probably very cheap, but they want the processor speed to be very high. And once you have that kind of conflict, you don't get any results. What's actually really, really hard is that people often don't make a compensatory decisions. So they are not aware of how to trade off the value of one attribute against the value of another attribute. Okay? And when they don't perform this type of decision making, the trade-off decision making, their accuracy is just not going to be very high. And also most people, when they come to the site to find a product, what they really want to know is to learn the domain knowledge. Okay, what kind of PC there are, what type of features you offer, and even the conflicting or the constraints among the features educate the users about the domain knowledge. So anyway, so the task analysis gave us an opportunity to come up with a requirement catalog. And I list 5 of them, 6 of them here. It doesn't mean that a tool has to satisfy all of them in one go, but more you satisfy it, the tool is likely to satisfy users' needs. So the first one basically sets the overall tone of the tool. Basically, it's almost impossible to get the user to tell you all of his preferences before he sees one product. He will definitely go away. So what's really important here is to make this elicitation process incremental to the user. So we say here, incremental effort of elicitation. Second, we said, user, don't tell you your preferences in the order you want. So they may want to have their own sequence. So any order is very important. And then any preference. They don't really want to give you all of those feature preferences, but maybe a subset of them. And these trade-off analysis, even though they're not very good at performing it, but if they do, or if you instruct them to do that, it actually increases the decision accuracy. And then we also said the domain knowledge is very important, how to educate the users. So after this task analysis and requirement catalog, we were able to build a set of tools. We call it Smart Client Systems. And this was between 1998 until 2001. I'm not going to get into detail to describe all of those systems, and especially the AI part. What I wanted to show you, maybe still some demo, is the preference editor, for example, and example critiquing in particular. I'm going to try to do a demo out of this, looking up here. Okay, so let me just clear out everything. So this is actually the beginning of the system. So what I type is my the departure airport, and the demo effect. It's really hard. This is HCI and my.
Move upward.
Getting better. Okay, so when it was built, it was connected to the central database. So it was able to find all of the flights of the 5,000 airports that we represented in this system. But unfortunately today, it costs a lot of money to connect to those central database systems, so I have to run a offline mode. Okay. But this can show all of the 5,000 airports. So without defining any of the time, departure time and arrival time, and also for the trip back, I'm able to see those flights here in the screen. But what I can do is that I can take the output. Okay, so this is the output of the flight here, and turn that into input. Why? Because I can edit any field. And now, because I'm in that particular context, I'm able to perhaps describe a preference that is really important to me. So, refresh. And when this constraint or preferences cannot be satisfied, it will tell me that it cannot be satisfied. It's in conflict. So in this thing, I'm also able to, for example, edit this and remove the constraint. I have an overview of the flights by showing me the departure airport, the date, and the different times that the flights take off, and the intermediate airport. For example, I can say not Zurich, then it will refresh. It can show me the trade-off between the various features. Well, here, if I have different prices, I will have a more interesting visualization. But unfortunately, this is all the same price. However, if I change it to number of stops, then I can say for the different, this I have to stop 2 times, and this one only 1 time. Okay. Another system that we developed that satisfy our requirement catalog is the vacation planner, in which we said, here we don't even ask user to give us any type of information. They could just look at the entire catalog, all packages here, for example. And they are learning about the domain knowledge here, and so they could select the destination where they wanted to take the vacation. I don't know why it's all gone here. It's pretty hard to do the demo while I'm down here. But the idea is that any feature, any order the user want, and they can also put in the constraints that are important to them, and gradually select their final vacation package here. And this type of research work, along with some other universities' research work, for example, the START field research development work at University of Maryland, essentially led to the second generation interface for product search. So the first lesson, if I can conclude for this part, is, well, AI made us think about the problem from the machine point of view, whereas HCI says humans' needs, if you can understand the human needs, you are able to design the system to help them. And the key lesson here is to keep it simple. The user-centric design therefore takes into account our human decision behaviors and help us design tools to enhance their abilities. So normally we say keep it simple and stupid, right? But stupid means what? Means the users or the system. Very often we're kind of confused with simplicity and complexity. Right? We kind of say simplicity, so well, it's easy work here. And in fact, making it HCI out of those AI work actually takes a lot more effort. You know, our estimate is like the 20%. These usable interfaces would take 20 to 30% more time to develop. And what humans cannot do, we must do it for them. So here I wanted to talk about the Larry Tesler's law of conservation of complexity. Right? So he is the chief designer at Apple, and he basically said, when the interface appears to you simple, what's behind it is quite complex. So here what I want to show is the complexity of designing these HCI systems with AI's technology. And in particular is the interface on example critiquing. The example critiquing interface will help us not only to select our items from the recommender system, but also help us do the trade-off analysis. To show you the interface, the first interface that we came up with to do this, so essentially we show the user the item that he or she is looking for, but usually he is not satisfied at that moment. He wants to compare with something else. But what does he want to compare? He doesn't really have a very concrete idea. So here the interface says, well, if you like something, then you just keep it. But most likely he wants to improve on certain features. So for example, here he is improving the price of that camera. And knowing that when you gain something, you might want to be prepared for your sacrifice. So here it says, these are features, if I click on them, it means that I'm ready to compromise. A very, very simple interface again, but it does a great job for the user. And you may say, do you have any proof? So for a number of user studies that we did, we actually saw indeed the increase in decision accuracy while the user were using example critiquing. So in this particular user study, we show that if they just use the first generation system, their decision accuracy is something like 18%. And then we want them to do more trade-offs, their decision accuracy increased up to 57%. But moreover, decision accuracy is not everything. What's really important is after the trade-off, they actually become more certain about their preferences. and also they become more certain about their choices. So we see here another user study to prove this. And moreover, the example critiquing user study revealed that because they cannot do this trade-off so well, what they really welcome is the AI part, the automatic generation of those critiques. So instead of doing this laboriously, right, to keep the features, improve features, and take some sacrifices, it would like to, most users would like to have the system to suggest already those trade-offs. So less optical zoom, for example, thinner and lighter weight, different manufacturer, and lower resolution and cheaper. Right? But what we also found out that if when users don't like those suggestions, they get very upset. So now the deal is to use AI techniques to generate those critiques that users are prepared to accept. And so we call that critique generation. And we used a priori algorithms, for example, to generate one of those preference-based critiquing generations. And here is an example. So when we show them one product, we basically compare this product with the rest of the products in the catalog in order to generate those vectors. And these vectors become the input to the a priori algorithm, and eventually it will give the system some idea what it is that we can automatically generate for the user. So in the final part of my talk, and I will go over these slides rather quickly. So HCI, you would say, what's the big deal? You're just doing interaction design. But interaction design is actually the part where you can turn that into engineering approach. We have the design task analysis. We have these qualitative and quantitative survey techniques. Then the interface design will appear to most people like an artistic endeavor, because after all, it has to do with color, has to do with rendering it into something that look very attractive. But in fact, there are only just few principles, and these are the principles I teach in my class. So in all those improvements of the interfaces that I show you, what I'm actually doing is just to organize the interface and use layout techniques and contrast technique and color technique to improve both the usability and the attractiveness of the interface. This interface that I showed to you was actually very crude. You see, I have here these interface input boxes, and then it's really far away where I have to type in. It's not logical. So there are actually quite a number of things to improve. And here, when I show you the details, I have a lot of tabs. I'm overwhelming the user. So realizing all of those mistakes, if you will, I can come up with a much more usable interface and much more attractive at the same time. Take out the gray color, right? Make it white, much more visible, so the results are much more visible. I group things so that users can follow, really hear the task. So I'm not confused. At each moment, I am only focused on one task at a time. This I can improve it further to make it more corporate-like, to attract the user of business travelers, for example. This one on the left, it looks like an interface that I can do in PowerPoint, right? It doesn't look very realistic. When we set up those user studies, we want people to think that it's actually an online shop. We simulate the shop. So we need these logos. We need an appearance that tells the user it's a professional website. It sells items. So just few of those details will allow us to build the interface in a more attractive way. This is about using visual icons to do the trade-offs. And then when we want to build trust with user, which is important in online environments, we want to explain to user why an item was recommended to them. So we experimented with a number of what we call the explanation or why interface here. And then the why is a long list, so we group them together, and this achieves both the objective of explaining the different categories of products as well as the explanation. And we also use eye tracker to find out where users actually look and their attention pattern. So, for example, a list view to show the results, which is the interface used very often in product recommender, we realize that users' attention is basically in this area, in the T area here, and very little attention is allocated to the bottom of the list. When we did a simple rearrangement with the layout technique and labels, they looked a lot more. They paid a lot more attention to the results. In fact, it actually increased the attention and increased the decision accuracy when we give them this grid layout. So there are 4 parts in this interface. And we found out that users much more prefer those organization interfaces than the list view. Once these results were obtained, we did another experiment. Here we made a simulation of Amazon website. Here, their recommended system only show everything into a list. Not only if people feel that this does not provide any diversity, they practically are not attracted to this because they don't ever click those buttons to see other products. So we did a simple reorganization, another layout, by changing the bottom of this interface into an organized view, and the result is like 65% of users prefer the new interface versus the 20% of users for the list view. So all of those principles, like filling the space, reorganize the information, and using layout techniques to display something, the information design, can be also applied to a website. And this is not really to pick on the EPFL website, but sometimes students will say, what about the EPFL website? What can we do about it? So the first thing is to fill the space. And why do we have all this white space, and why do we want to hide the information about the different schools, the faculties we have? Why don't we just put them all here? Right? And then, well, the news and the events can be also reorganized with a little bit more buffering and those boxes in order to make this interface much easier to read and also much more correspond to the image of our university, which is the leading university in the world. So I wanted to conclude this talk by giving you a model here, which is called interactive intelligence. It is about using AI techniques to enhance the work in HCI, but also use the HCI methodology to influence our work in order to build systems that can help people solve difficult problems. And the difficulty here is to find out opportunities when user needs the technology, needs the AI, we want to grasp those opportunities and give them this engagement design that they're looking for. So, acknowledgement, I like to thank my former students as well as my current students and colleagues in contributing to the work that we do in the HCI group. And that's the end of the talk. Yes.
I have two questions, and I'll ask one, and then let people ask another. But I was wondering when you gave us the example of the flight selection, I was thinking that perhaps what I would like to start with is a one-paragraph description of what I'm looking for. Like, I want to fly from here to there, and I'd like to arrive before then, and I do not want to fly on, certain airlines, blah, blah, blah.
Yeah.
Do we have the technology today to actually be able to understand this paragraph, even if just approximately? Or are we still sort of at the point where the user will have to click, select? All these constraints, can they be extracted out of text?
Okay, so you're saying natural language interfaces.
But maybe not
and
I'm thinking about keywords, just picking out keywords like, Geneva, yeah, that sounds like an airport. Swiss airline, that sounds like an airline company. Can we do that?
I don't know if there are any technology that can provide this type of interface. I would say no. But you're also implying some kind of a key completion type of interface. So you can do that for queries, right? But that's using statistical method to find out if I type Geneva, what would be the next word. Yeah. So maybe there's some possibility to look at lots of queries that people have typed, and when they type Geneva, what's the most likely destination airport they want to go to. But other than that, it's still second guessing. And whenever you do second guessing, our experience is that users are not very happy with that. Yeah.
Yeah, maybe one question about the airline and also the selection of vacation packages. You might know route rank, right? You know route rank. So they say, okay, if you choose this option, then your impact on environment is going to be that much. So many tons of CO2 you're going to release. With the system you are proposing, essentially you are going to make it easier to burn more fuel, right? You go to car ribbons and go to whatever, right? So how do you bring a little bit of environmental consciousness in those systems? Why are you laughing? You're in the 21st century, right? It's a modern question, right?
Yeah.
Yes. So
No, I'm laughing. I think it's a difficult question. So the system can only configure or propose or recommend items to you based on information that has been represented in the system.
Sure.
So if we could relate vacation packages to the environmental parameters, then we would be able to make it conscious to the user that indeed when you select something
you can.
Yeah. I think if this information is integrated, yes, you can.
You can integrate it, yeah.
And actually it makes a very good occasion for the trade-off.
Yes.
So if you are somebody who are environmentally conscious, then this type of critiquing system will say to you, well, this vacation package might satisfy your needs for the sea and beach vacation, a lot of fun, but be aware this consumes tons of fuel and yeah.
So how do you see interaction with social networks, for example? Like you want to buy a product and many times instead of typing of all the features, like what are the features you're looking for. You can say this is your budget, and this is the most recommended product with so many likes and so many star ratings. So how do you see? I mean, because I see there's like a lot of integration between social networks and this. So how do you see this?
Yeah. So in fact, in my group, a number of my students are working in this area: social decision, social choice, and the influence of friends in your buying behavior. But also your choice behavior. And there's a great potential in this field because, as I said, the choice and decision problem is very difficult. But people seem to listen to their friends a lot and willing to be influenced. So when we integrate that information into our decision process, again, through those interviews, needs assessments, we're able to build interesting interaction models. And we already have some results in this area. Yeah.
So I was just thinking that so when Christoph Koch gave the talk, and I remember that he was somehow implying that the way that databases work is just not a natural way how humans like to, I don't know how certain problems are solved. Do you think that that limits the interfaces, that simply the database is just this completely unnatural way to search humans?
So if there were
interface, or is it something that has to go deeper than that? Maybe the interfaces are like that, because the databases are.
Yeah, so the database, in fact, is the query process that can be actually very awkward. And the first generation interface that I mentioned, in fact, not only it's the phenomenon by the AI systems, but also by the way people or the database system were designed to provide this kind of query process. So it was actually also a concern in the database community to change the way database was designed, first of all, and how people can query the database. In fact, some of our work, like the constraint satisfaction work that we did on the AI side, we practically had to throw away all of this code that we did on this decision representation on the first trial, because people don't behave like that, and they go away when you ask them to give you these value functions. This is really a turn-off. Yeah. But the fact that today Amazon, for example, and Yahoo all employ these much more fluid interfaces, I have believed that their database has changed. Yeah. This George.
First of all, people are interacting with computers more and more, and they are more and more connected with everything, with digital information. And the systems get to know people's preferences a lot better, more precise, more accurate. For example, like looking at a video, the system will get to know what I would like to see on my mirror in the morning. So the question is, how would you see the future of interaction from this point of view? Computers knowing people's tastes more precisely.
Yes. I think it's a great opportunity to use the behavior that the system are able to accumulate on the user for their advantage. But we have a lot of privacy issues here. We also have user in control issues here. Many of you remember the clip agent in Microsoft Word, right? It says, George, it seems like you're typing a letter, okay? You probably get very turned off and upset. But you type a query in Google today, it gives you a key completion. Why don't you get upset? Right? It's the same thing. It's an assistant. But you see how it comes into your process. The first case, you're typing a letter. It's pretty obvious, and it's something very simple, or it's something you say to the clipper, it's none of your business, right? But when I'm typing the query and the second word becomes difficult, or I don't even know what would be the best word to use, the key completion is very welcome. So it is really finding the sweet spot of when to deliver this intelligence to the user that is at stake to what you're asking. Okay, so definitely the behavioral pattern, what we know about the user, we need to use this information to help them decide, help them navigate. But if you choose the wrong moment, it's very risky. Yeah. One last one.
My perspective relates to both of the last two questions. So by way of background, so my experience with web search was first Yahoo, to the portal.
Yes.
And I had to select, I had to decide what I was looking for and so on. And if we forget about Alta Vista, then came Google and gave me one box, and in which I type what I'm looking for, and maybe I have to try a couple of times, but I get what I need. So I think that's an example of where the database didn't change. It's still the web, but it was really the interface on top. It's kind of related to what Matthias was saying. And the other thing that relates to what you had on one of your slides, where you said, well, if you make this, so a simple interface will have behind it a lot of complexity to try to make it simple. What is the HCI community's view of, for instance, this particular case of how Google has sort of pushed this notion of simplicity in their interfaces to the max? Is it something that in the HCI community was well understood before Google started doing it? Or is it something that Google did it commercially, and then all of a sudden people start realizing, oh yeah, actually web pages that have a lot of flashy things and so on, they're not good for us. Is there, or does the HCI community think that this is trivial stuff?
So there are many layers of questions in your question, actually. First of all, I think the HCI community recognized the fact that many of the existing software do not readily satisfy user needs. And so we've been promoting this type of task analysis, these type of usability engineering approach in order to make it more usable on the interface and the interaction part. And this is the fact that it requires software engineers to make more effort. So if database doesn't give this kind of query process, we will want them to redesign, right? Or rearrange something in order to satisfy users' information needs. So that is one question, right? Now, the simplicity of Google being the kind of the case for simplicity, it's not really that simple, actually. There was also marketing effort, because you remember there were lots of search engines. Now, there's another search engine. How could it stand out? So maybe this was their marketing, some very wise decision to make it very simple. Does it mean that it is necessarily works? I'm not sure, because a lot of space is unused, and today there's the Google interface which gives you weather information of where you are. Some of the YouTube clips. I personally like that space, the new interface more, because I can do more things in one go, one page. I don't have to, go to another site or look for it consciously. But it's also a cultural thing. Like we can think of using Google search toolbox in another country. People find, oh my God, it's so empty, So there's also a cultural issue. Keep it simple generally means good, but if you also trade off other things, like you need to do more interaction, you need to click more, then you might want to think about your design in a different angle and then say what is your sweet spot for complexity, but lots of power and simplicity and usability. So, anyway.
Thank you.